When is set to be, so here what I want to say is, so you may be given wantedly, if P is an interior point, which of the following are true? So you may be given this, or you may be given P minus 1 by n square comma P plus 1 by n square subset of n. In place of epsilon, you can have anything which goes to 0 as n tends to infinity. You may have 1 by 2n, 1 by 2n plus 1, 1 by 2n minus 1, 1 by n cube, anything you can have in place of epsilon. Next one, open set. A set S is said to be open set if it is in the neighborhood of each of its points. That means P minus epsilon, P plus epsilon is contained in S for all P. Then we say set is open set if it is a neighborhood of each of its points. That is, every point is an interior point. So a real number P belonging to R is said to be interior point of S if P minus epsilon, P plus epsilon is contained in S. So there are two definitions. One definition is a set is said to be an open set if it is in the neighborhood of each of its points. That means S should be in the neighborhood of P minus epsilon, P plus epsilon for every P, not for some P, every P. In general, S interior, that is set of all interior points, is subset of S. A set S is said to be open if every point of S is an interior point. That is S interior equal to S. When is set said to be open set? Open interval is different, open set is different. A set is said to be open set if every point of it is an interior point. That is S interior is equal to S interior. Then we say it is an open set. Next, if P minus epsilon, P plus epsilon is contained in S for some epsilon, then we say S is in the neighborhood of P. Number 2, P is an interior point of S. Next, find the interiors of the following and check whether they are open sets also. So many problems are there. How to check whether it is interior open set or not? Find out S interior. If it is equal to itself, open set. Otherwise, not open set. Don't say not open means closed. Door is not open means closed. It is not like this. A set is not open does not mean it is closed. Don't write that. Wantedly they will give an example, a problem. S is an open set. S is not an open set. S is a closed set. So generally students are of the impression if it is not open means closed. So they mark closed set, and that's where the bit goes wrong. So in the general sense, whatever words we use, they are not the same as mathematical definitions. So interior means we use in the sense of inside. But here we have seen interior is different, inside is different. Belonging to is different, interior is different. Similarly, open set and not open set means does not mean closed. Not open means not open only. Closed we'll see later. Because there are certain sets which are neither open nor closed also. So you must be careful. So at present, find interiors of the following. Check whether they are open sets or not. How do we check? After finding S interior, check whether it is equal to S or not. Is equal to S, open set. Otherwise, not open set. Now let us take this AB, closed interval AB. So let us work out the problems. Answers are not there in this. Note down. So let us start. Take down the answers simultaneously. First one, S equal to AB. Tell me what is S interior?
Open AB.
Implies S interior is open AB. Correct. Good. Now, can we say these two are equal?
No.
Are these two equal? No. So, which implies S is not equal to S interior, which implies S is not equal to S interior. Therefore, is it an open set? Is it an open set? No.
Not
right
open
now.
set, ma'am.
So, which implies S is not an open set. Therefore, S is not an open set. S is not an open set. Write down this like this one. Solution. S equal to closed interval AB. Then S interior will be open interval AB. So both are not equal. Why they are not equal? No? In this A and B are included. Here A and B are excluded. So this contains 2 points extra which are not there. What are the extra points this contains? A and B. Both are not equal. So S is not an open set. So write down that point. Therefore, S is not an open set. Therefore, closed interval AB. Therefore, closed interval AB is not an open set. Therefore, closed interval AB is not an open set. So closed intervals are never open sets. Not an open set. So suppose you are given in the exam, which of the following are open? In that, if closed interval you are finding, it is not an open set. So try to remember this. So closed intervals are never open sets. Next. Number 2, point number 2. Take down the solution simultaneously. S is equal to open interval AB.
Open interval itself.
What is S interior therefore?
Open interval.
Open interval.
It is open interval.
Therefore,
Very good,
S
very good.
equal to S interior. Which implies
It is open.
S is an open set. S is an open set. So every open interval is an open
It is an open.
Write down. Therefore, open interval is an open set. Open interval. As an interval it is open. As a set also it is open. Open interval is an open set. Open interval is an open. Let us go the third one. Take third one. Solution for third one. So remember, closed intervals never open sets. Open interval is always an open set. Now let us see about the semi-closed interval.
Open interval.
So let us see. Number 3. Question number 3. Take the solution. S is left closed, right open. What is S interior more?
Open interval.
Open interval. For semi-closed, closed, open, S interior is open.
Another open interval.
Open interval AB. Are these two equal?
No,
Is
ma'am.
S equal to S interior? No. Why not? Because here A is extra there, here A is not there.
It is not.
A is not there. So S is not equal to S. Therefore, S is not an open set. S is not an open set. That is, semi-closed are not open. Therefore, semi-closed, left closed right is not an open set. So semi-closed intervals are not open. So for example, in the exam you are given, is this open set or closed set? This is semi-closed interval. This is not an open interval. This is not open set also. Neither open interval nor open set. It is a semi-closed interval which is not an open set. Okay. So next one. Not only doing the problems, you need to remember results so that you can save your time in future. Next one. Number 4. Number 4. Left open, right closed. S is equal to left open, right closed. What is S interior more?
Open interval A, comma.
Open A comma. S is not equal to S interior. Because here extra B is there, here B is not there. Which implies S is not open set. S is not an open set. Not an open set. Not an open set. Okay. So say left to open, right closed is not an open set. Not an open set. Next one, number 5. Number 5. Number 5. S is equal to left closed, right open. What is S interior?
Open interval.
Open interval A comma infinity. Not equal to S. Therefore, S is not an open set. S is not an open set. Not an open set. Emma? So in the exam, how the question will be given? For example, you are given whether -1 comma infinity closed. Is it open set means answer is no. Semi-closed, whether it is with a finite endpoint or infinite endpoint, are not open sets. Only open interval is an open set. Only open interval is an open set. No other intervals are open sets. No other intervals are open sets. Only open interval is an open set. Semi-closed, closed, they are not open sets. Next, number 6. What is number 6? Minus infinity A. Closed. So what is S interior? Minus infinity comma open interval. Again not equal. Therefore not an open set. Not an open set. Don't write simply not open and leave it. Is it set or interval? That is important. So not an open set. Write that point. Later again you will get doubt. It is not an open interval. Why we are doing all this? So we are trying to test whether it is an open set or not. As an interval, we know it is not open, but we want to know as a set, is it open or not? Next, let us do number 6 star. What is 6 star? 6 star is S is equal to open interval A comma infinity. What is S interior, ma?
Same, ma'am.
This
Open
implies
interval.
open interval. Write down that form. A comma infinity. So S equal to A comma infinity implies S interior is also open interval A comma. Are they equal or not?
Yes, ma'am.
Equal to S. Which implies S is an open set. S is an open set. Suppose it comes in the entrance, then you need not do all this. This is for you to understand your notes later. When you look at S itself, you will be able to see it is an open set, because being an open interval, it is an open interval, maybe with infinite endpoint. So every open interval with finite endpoint or infinite endpoint is always an open set. Any other interval other than this are never open. So remember this as shortcut. Okay. So next one. Let us do now 6 double star. What is 6 double star here?
Hey.
Question. 6 double star is yes, note down. S is given to be minus infinity comma a, open. What is the S interior therefore? S interior is equal to minus infinity comma a, which is not equal to S. Therefore, S is an open set. Because S interior equal to S, S is an open set.
Not open.
It's open. It is open. Because open interval, this is also open interval. For open interval, what is interior? Open interval only. S equal to S interior. So it is an open set. Previous one also open set. Every open interval is an open set. Whether it is with a finite end or infinite. Next. We have A infinity, minus infinity A6 we have completed. Number 7 now. Take down number 7. S is equal to R, which implies S interior is equal to. What is R means? Minus infinity comma. It is an open interval. For an open interval, interior is itself. R itself. A comma B, S interior is A comma B itself. S interior is equal to S. This implies S equal to S interior. Therefore, R is an open set. R is an open set.
Charging.
Next. Number 8. Number 8. If S equal to N, I hope you are taking down. You are taking down simultaneously. Is it not?
Yes, ma'am.
Yeah. Next. If S is equal to N, this is number 8. If S is equal to N, then S interior is 5, empty set. Which implies S is not equal to S interior. Therefore, S is not an open set. Not an open set. Next one, number 9. S equal to Z. Number 9. S equal to Z. If S is Z, number 9, S equal to Z. Implies, what is S interior? Earlier we have discussed
Empty.
Empty set.
Empty set.
Which implies S is not equal to S interior. Which implies S is not empty set. Not open set. Therefore, Z is not an open set. Therefore, Z is not an open set. Therefore, Z is not an open set. Next. Which bit now? 10th one. S equal to Q. What is S interior?
Empty set.
Empty set. Why we have seen in the beginning? This implies S is not equal to S interior. Not equal. Therefore, Q is not an open set. So you will be asked to identify which of the following are not open. In that R, Q, N, Z will be given to you. Then more than one correct option also you can expect this. Next one. R minus Q. If S equal to R minus Q, what is S interior?
Empty set.
Empty set. Therefore, again you justify why it is so. after class or tomorrow you sit when you are at peace, sit with your books and then do it. Which implies S is not equal to S interior. Which implies R minus Q is not an open set. Is not an open set. Some students are having an impression Q is not open, therefore R minus Q may be open. Answer is no. Neither Q is open nor R minus Q is open. Okay? Next one. So don't have such a generalization. Because why you get that is, if X is not there in the set means it is there in the complement. You studied somewhere in your 10th class. So suddenly that comes to your memory, then you are out. So Q is not open, R minus Q is also not open. Okay? Next one. Number 12. Z is S equal to R minus N. What is S interior, ma?
R minus N.
R minus N only, because union of open intervals, which implies S equal to S interior, which implies R minus N is an open set. R minus N is an open set.
आधी आधी का आधी थोडा आवाज कमी कर.
Next. 1, 2, 3 and so on up to N. S is equal to 1 to N. Which implies S interior is
Empty set.
empty set for finite. So which implies S is not equal to S interior. Therefore, yes. See, one important thing is 1, 2 and so on up to N is a non-empty finite set. What is this called? Non-empty finite set. Non-empty means at least one element is there. Finite means you are able to say how many. Therefore, this non-empty finite set is never an open set. So write down that point. You may be given among options. Every finite set not open. No. Every non-empty finite set. Empty set is always taken as open set. Remember. Empty set contains how many elements? 0 elements. It is finite. You are able to say how many. So empty set is a finite set which is all open. And non-empty finite set is never open. So can a finite set be open? Suppose you are asked to write, can a finite set be open? Answer is yes.
Yes.
Yes. Can a non-empty finite set be open? Answer is no.
Never. Never.
Very important. Write down that point. I will give you that. So at present you take down this. Which implies, very important, which implies every non-empty finite set, which implies every non-empty finite set, non-empty finite set is not open. Every non-empty finite set is not open. Take down next point. Note. Empty set phi is regarded as an open set. No, empty set is always regarded as an open set. Is regarded as an open set. Therefore, empty set is an example of. Therefore, empty set is an example of finite open set. Empty set is an example of finite open set. Example of finite open set. Why finite, ma? Because how many elements are there in empty set?
We can
No
count one.
element. It is 0. You are able to say or not? How many? 0. 0 is a finite number. Therefore, we say it's a finite open set. See, you know that empty set is always regarded as subset of every set. It is an axiom. Similarly, here also. Our assumption is empty set is always regarded as an open set. Because nobody is able to disprove it. Unless somebody disproves it, we take it for granted. It's an open set.
Mother.
Next. We have next question. Take down the question. Can a finite set be open? Take this question. Can a finite set be open? Can a finite set be open? What is the meaning of this? Can a finite set be open means, is there any finite set which is open? That's how we have to understand the question.
No.
Can a finite set be open means, is there any finite set which is open or not?
No, ma'am.
Why no? Empty set is there.
Yes, empty set is there.
Empty set is there. It is finite open set. What did I say? Can an empty set, can a
Yes,
finite set be open? I did not mention empty or non-empty.
Okay.
Can a finite set be open? Answer
That is empty. Empty set.
Write down. Can a finite set be open? Take down the question. Can a finite set be open? Answer yes. Within bracket you can write down empty set is a finite open set. Empty set is a finite open set. Is it clear, ma? Here most of the students will write no, like Bhagya said. So you have to be careful there. Is empty, non-empty given or not? If that is not specifically mentioned, answer is yes. Next. Can a finite, next question. Can a finite non-empty set be open? Next question.
No.
Can a finite non-empty set be open?
No, ma'am.
Write down. Can a non-empty finite set be open? Can a non-empty finite set be open? Answer is
No.
no. Again, among options will be given yes, no, need not be. So answer is no, definitely no. Definitely no. Next one. Emma, am I clear in this?
Yes, ma'am.
Right. Write down next question. Is every infinite set open? Write down the point. Is every infinite set open?
No, ma'am.
Write down the question.
Yes, ma'am.
Write down first question. Is every infinite set open?
No, ma'am.
Is every infinite set open? Answer is need not be. Need not be. You cannot say no. Need not be. Need not be means there are certain infinite sets which are open. There are certain infinite sets which are not open. What is the example of infinite set which is open?
Real numbers.
Real number systems. What is the infinite set which is not open?
Integers to natural numbers.
Integers, natural numbers, rational numbers, irrational numbers, they are all infinite, but not open. Also, closed interval A comma B is also an infinite set, but not an open set. Write down that point. Answer is need not be. Because. Answer is need not be because R is an infinite set. Because R is an infinite set which is open, but n, q, r minus q, z, closed interval ab are infinite but not open, or infinite but not open sets. Infinite but not open sets. Infinite but not open sets.
Excuse me, ma'am.
Yeah.
Can a finite set be open for that option can be may or may not, ma'am?
No. Can a finite set means is there any finite set?
Okay, ma'am.
So is there any finite set means there is finite. Here I have used the word every.
Yes, ma'am.
Is every infinite? I have used the word every.
Yes.
Is there any infinite set which is open or means yes. Is there any infinite set which is open or not means yes. Correct. Is every infinite set open? Need not. See, understand the question carefully. How close it is. It's a concentrated subject. Next. Is it okay? Or any more doubts? Any more
No, ma'am.
doubts?
Clear, ma'am.
No, very clear. No. So every finite set you cannot say open. There is only one finite set which is open, namely empty set. Because every non-empty finite set is not open. Somebody may get a doubt. Can we conclude therefore every infinite set is open? Answer is need not. Because there are infinite sets which are open, there are infinite sets which are not open. Next. 8th one completed, 9th one completed, 10th one completed, 11th one also completed. Is that
All are completed, ma'am.
12th one.
Is
12th one also
completed, ma'am.
All
Okay,
are
okay,
done, ma'am.
okay. Okay, up to finite set. We completed all. Okay, good. Then here, intersection of two open sets. Is it an open set? Yes. Intersection of open sets is always an open set. Then the question comes, is it finite intersection or infinite intersection? Obviously. So, intersection of finite number of open sets is open. So, take down this. Take down this. If M1, comma M2 and so on up to Mk are open sets.
So is that means
M1, M2
intersection
and
of
M2,
open
Mk
set?
are open sets. Then M1 intersection, M2 intersection, and so on up to Mk is also an open set. M1 intersection, M2 intersection, and so on up to intersection Mk is also an open set. Is also an open set. Next question obviously comes. Is infinite intersection of open sets open? Obviously. So infinite intersection always comes under arbitrary intersection. So arbitrary intersection of open sets need
Is
not be an open set. So infinite intersection of open sets need not be an open set. So example, 1 minus 1 by n, 1 plus 1 by n is an open set for every n. Why? Because every open interval